Now we come to the important part, and that's how we hook those 6 wires to the flight controller. And right now I've got the little receiver right here on the table, and I've got it connected via the black and red wire, as you can see right there, to my bench power supply right there. And this is the control program for my bench power supply. It's controlled via USB. I've got it set for 5 volts and 3 amps right now. So go ahead and click this, which will switch on the power supply. We have 5 volts. Down here it shows we've got just right at 0.5 amp, 0.05 amps of power being absorbed by the receiver. Over here on the table, we can see that the receiver is powered up, and if I turn on my transmitter,
welcome to OpenTX manual mode.
You can see it's already bound to my transmitter. So I do have at least minimum my ground and power wire correct, and like I say, it has been bound to my transmitter, both my transmitters in truth. So this will let me start figuring out how I'm going to hook it to the H743 wing version 2. Got a version 3 out now. How about that? So it's going to go right down these 6 pins right here on the flight controller. Ground, black wire, red wire is going to be hooked to the 4V5 voltage. UART6 receive and UART6 transmit are both going to be used for the RC signal, the control signal. CRSF, transmit and receive right here. And then UART4 receive and transmit are going to be used right here for MAVLink telemetry data. So that's the way I'm going to set it up. Now the reason I powered that up on my bench power supply and connected it to my transmitter is so I can show you some of the quirks about the pinouts. This is the TBS Crossfire manual for the Nano Pro RX. We'll be talking about these connections right here, first 6. Scroll down to this. I'll use this later for a complete wiring list, wiring diagram. Of course, the first one, ground, can only be ground. Nothing else can be there. Next one is 5 volts in. That's all that should be there. Whereas these next 6, 2 right here and these 4, can kind of be programmed. I will be using one of these 2 later for RSSI, but right now we'll just set that aside. I'm going to be using these 4, channel out 1, channel out 2, channel out 3, and channel out 4. I would love to set them up for CRSF transmit, CRSF receive, MAVLink transmit, MAVLink receive, so they would match exactly with my 743 flight controller, but that's not possible. The reason that is not possible is because when setting these channels, we have to go by this list. And you'll notice there is no CRSF on channel 3. We'll just look at real quick. There, the MAVLink is a receive only. There's no MAVLink transmit on channel 3. That comes in on channel 4. So I can set up my channel 1 CRSF transmit. it can't be set receive either, but that's okay. I want to set it transmit because I know that the pin on the flight controller, let me pull that up real quick. Just the way most of the Maytag flight controllers are set up, you can see that if the pin 2, this pin right here, when it's made transmit, that goes straight over to my receive on the flight controller. And when this pin is made receive, that goes straight over to my transmit on serial 6. And if I could make this pin Mavlink transmit, that would go over straight to my receive on this controller, but that's not possible. So what happens is this pin is going to be the Mavlink receive, because as this says down here, you can set 3 to Mavlink receive, but you cannot make it Mavlink transmit. Mavlink transmit is here. So I will have to make 3 Mavlink receive. This will have to be Mavlink receive data. Therefore, this transmit out of UART4 will have to come over to that pin. And this will be Mavlink transmit, and that will go over to this pin. It's a little bit of a bummer, but what goes on here, these 2 are CRSF, these 2 are Mavlink, but because of the way Crossfire is assigned, it's transmit, receive, receive, transmit for the receiver, and therefore these 2 wires right here have to be crossed over. The way it's set up, these can sort of come straight over. I hope I'm making a little bit of sense here. And that's because of this list. So you've got CRSF transmit, CRSF receive on 2, and then you've got Mavlink receive on 3, and Mavlink transmit on 4. So we'll just go ahead and use this wiring diagram. Now we'll jump over real quick to TBS Agent X. Here's the Crossfire Nano RX Pro. Here's the output map we've been talking about. This is kind of the way it comes up by default. So CRSF TX is already there, and CRSF RX is already here. Now, I'll just illustrate real quick. Make this channel 2, make this channel 1. There we go, channel 1, channel 2. And so now we'll just go down in this list. You'll notice CRSF transmit is not there. Channel 2 cannot be made CRSF transmit. I'll make it receive. Of course, that makes the first one CRSF transmit. Then we have output 3 here. I cannot make it Mavlink transmit, but I can make it Mavlink receive. And then 4, we can make that Mavlink transmit. So there they are, transmit, receive, receive, transmit. And that's the quirks. Now channel 5, by the way, you can set it 1 through 12 RSSI, LQ, RSSI, NQ, or best SCL. That's it. You can't set anything else on 5. Let's see, I need to leave that 5, don't I? And 6 is the same way, according to that chart. That's all you can set there. So basically, this is the way I will have it set up. I'll probably come in later and do this right here and set up RSSI. We'll get it all running, then we'll work on the finer points. So right here is transmit, receive, transmit. Real quick, I'm going to jump in here. I'm going to set mine for 12 channel mode, telemetry on, telemetry power. We'll talk about this again later, because if this is set to max, it sets it to half a watt, which is the power output of the light controller. The 4V5 voltage max is 0.5 watts, 0.5 amps, I'm sorry, 500 milliamps. And we'll talk about CRSF a little deeper later. Fail-safe mode cut, dynamic power, of course. I will probably set this to mid, no higher than at first. We'll leave it minimum for the bench. The rest of this is all good. So that's why this output map, setting these 4 values, is what's kind of a little quirky. These receives being in the center together and making me cross over these 2 wires right here, whereas the other ones can come over. Ground, voltage, transmit, receive, but we don't have transmit. We have receive next coming out of the receiver, and then transmit. So we have to kind of go ground, voltage, transmit, receive, transmit, receive. So I know that's a little strange, but I hope that's a little clear. Come back to this real quick. So that's what I've got here. CRSF transmit, CRSF receive, MAVLink receive, MAVLink transmit. So I guess I'm about ready to solder up those wires. Let's make us a good wiring diagram. So this is how my receiver will be wired. Ground on the bottom of the receiver will go straight to ground here using a black wire in my particular wiring harness. Red wire will take 5 volts right here from here to input here, 5 volts in here for the receiver. RX6 will be hooked to this third connection, which will be transmit, CRSF transmit. Transmit going to receive on the brown wire. And CRSF receive right here on a green wire will be listening to the transmit pin of UART6 on the flight controller. Up here, I have MAVLink receive going to UART4 transmit. And I have MAVLink transmit. Oops, that's the blue wire for me. And on the white wire for me is MAVLink transmit coming out of the receiver going to UART4 receive pin right here. And that's the way I am going to wire up the other end of that cable, connecting the Crossfire Nano Pro receiver here to the Matex 743 wing version 2 right here across ground, voltage, UART6 and UART4.
Well, there it is, the other end, the end for the flight controller soldered up, all 6 wires. I didn't put any shrink wrap on this time because it's going to go through that hole in the fuselage, and I didn't want it to be real stiff. But there's that one. It's ready to be embedded in the wing. And then after that, the wing can have the control horn on the aileron put on and the linkages, and that wing will be finished. Now I have to duplicate that receiver and cable for the wing for the other one. Well, there's the second receiver wired up. I did the heat shrink wrap a little different this time on the second one. I didn't bring it up to above my thumb here. I left the wires exposed so I could see the colors. As on the first one, when I started doing the end affixed to the flight controller, I forgot exactly how the green and the brown in there were. So all I have to do to this side now is attach the antenna and put the shrink wrap that came with the receiver onto the shrink it around this. That doesn't do much, but what the hey, they sent it with the receiver. I'll just go ahead and use it. That shrink wrap does go down around the board really well and kind of tight. I may have to make a little hole. Nah, button seems to push. Starts to say I may have to make a little hole to be able to push the button, but I can feel it clicking. So, doesn't do anything for it up here on the antenna end, but the rest of it down through here shrunk pretty tightly, and the rest of it really shrinks well around the circuit board itself. Such be life. 6 more wires to solder on the flight controller connection end, and we'll be done with this part. There's the second one done up. Receiver on one end, 6 conductor DuPont cable on the other end for plugging straight into the flight controller. I actually tested both of these real quick by that one flight controller where I killed the USB connector right here. The ground collar around it's torn off. And then that's the same one I damaged soldering down in this area, and the current meter wouldn't work right when I got ready to start to fly it. Glad that all happened to one flight controller. But I've just left it laying on the bench as a bench flight controller I can hook to for things real quick to test real quick. Anyway, so I put both the receivers on this board, hooked it to the USB, made sure the CRSF worked. It does in both of them. I did not test the MAV link because I don't have any maybe, I guess I could have. Started to say because I don't have any GPS or hooked in any of this, but there's much more MAVLink data than just GPS data that's inside here. For instance, the accelerometers in here have instantaneous data. So I may hook it back up and test the MAVLink real quick just to make sure it connects. Probably won't video that. So now I've got to put the 2 receivers in both the wing halves, and that pretty much finishes that up.
I redid my wiring diagram. Set it up like this. Maybe this explains quickly, more easily, what I did with these. This is the way, you don't assign the ground or the input voltage inside the TBS Agent XM, Agent Light, any of them. You can control these other 6. And this is CRSF transmit going to receive UART 6. This is CRSF receive going down to the transmit out of UART 6 back to the receiver. This line can only be set to receive So it receives the transmission from the flight controller on UART4. And receives the transmission of UART4. And UART4 hears the MAVLink transmitting on this pin, and it receives it here on UART4. That's the funky part. If this could be set to MAVLink transmit and receive, just going down the line normal, then these pins reading across as they are, you wouldn't have this crossover in them. It would just be received to transmit here and transmit here to receive up here, but you can't do that inside the Nano Pro. I think you can do that in the Nano, the diversity. I think that's one of the other reasons, besides the big solder connections, that I have mostly shied away from the Nano and went with the Nano diversity until these two bills. So that pretty much explains, as best I can. Sorry about that. Just a hobbyist. An old electronics computer guy who's playing with drones now. I'm describing my experience. That's the way I wired both of them. And like I say, I have tested both of them attached to that other bench flight controller, and the CRSF works. I haven't tested the MAVLink yet. I will. I'm going to go ahead and publish this video. I next need to do a wiring harness for the two GPSs on the two Nano mini Talons and solder up two H743 controllers. And then I have the camera in hand for both of them. I just don't have the pan and tilt to go underneath it or the front deck done on the two fuselages. All of that's liable to get slowed down because my eyes are getting good enough to fly. And I won't be going to the eye doctor for his professional opinion until the end of May. I think May, let's see, what is it? I think May 31st might even be the date. On Tuesday, May 31st, I go back to him. That'll be 6 weeks after the second surgery and almost 2 months after the first surgery, first eye. I don't want to wait another month. I can't blow another month. I just can't. So I'm going to kind of start looking at using reading glasses and stuff for stuff up close, because I can, from a foot in front of my face to infinity, I can see great. Sunglasses work, the whole 9 yards. I don't know if I can see goggles yet if I put them on without using reading glasses underneath them, because I can't focus anymore, or what. But I'm going to kind of switch to that instead of these mini Talon bills. They're not going to go on the back burner. They're just going to have the burner turned down from medium to low, and I'm going to concentrate more on getting out and flying, or working towards that, because I got a few things I still have to work through, and I can't wait another 31 days, 32 days, whatever it is. All right, guys, that's the wiring of the Nano Pro Crossfire receiver to a Maytag 743 version 2. I am anxious to fly this, to test this MAVLink communication. This works. This is going to be sweet, sweet, sweet. Thank you.